In this video, we are going to go through the majority of the generate modifiers and a couple of deform modifiers. We will not cover the modify and physics modifiers in the intermediate tutorial series. I have tried to pick modifiers that I believe are more useful to you from an intermediate perspective. Any modifiers that are missed will be covered at a later point. Just before we start going through everything, I just want to quickly explain that these videos are basically a compilation of all of the modifier videos I've created so far. If you prefer to watch these videos in smaller parts, then you can go through my modifiers playlist on my YouTube channel and learn that way. Another quick thing I want to explain. Modifiers in Blender are non-destructive. What this means is that when you assign a modifier to a mesh, it will change the look of the mesh straight away, but it will not finalize the change until you apply the modifier. So for example, if I was to add a simple deform to our cube here, although it has been morphed, the changes will not be finalized until I come here to this arrow and hit apply. If you have applied a modifier but want to remove it, you can simply come here to this X, click it to remove the modifier. If I wanted to use multiple modifiers, I can do that. If you have multiple modifiers active on a mesh, then you can change the stack order. The modifier sitting at the top will always take priority over the modifiers at the bottom. If you want to change that, you can come here and choose move to last, or you can do move to first to move the modifiers around. So with the basics of modifiers covered, let's now dive into the modifiers in detail. Arrays create a number of copies of a mesh. It is a useful modifier if you want to create large scenes or create complex repetitive shapes. Let's have a look at the options we have here. The first fields we will look at are the fit type and count fields. The fit type essentially controls how the length of the array is calculated. With fixed count, we are granted this field called count, which simply allows us to specify how many times we want the mesh to be copied. So for example, if I change this from 1 to 2, it gives us an extra copy, 3 gives us an extra copy, etc. Fit length does something similar, but in meters. We can come here to the length field and specify how far we want the copies to go on for. So if I just scroll up on this, you can see it is generating the copies based on a distance. The last one here is fit curve, which allows us to bind the array modifier to a curve object, which I will show on this mesh here. With this curve selected, so this circle, which is here, the Bezier circle, if I was to go to the circle and scale it up in edit mode, you can see that the cone is creating copies based on the Bezier circle's length. Working our way down the modifier, we now see the various offset sections. Relative offset creates the copies based on the bounds of the base object. So to put that into simple terms, it is trying to look at the perimeter of the base object and make the copies outside of that. So for example, with 1 selected, I'm just going to come back to fixed count. With 1 selected, the copies are generated practically right next to each other. If I was to put in 2 here, you can see that it's given them an extra space, which is based on the size of the object. Again, I can put in 5, and it's given us even more space between each shape. Constant offset is similar, but it is based on meters. So if I was to come here to the x-axis value and scroll up, you can see that it is offsetting based on a distance. Now let's turn off constant offset and come to object offset. So object offset is quite a handy tool. It basically uses another object to control the offset of the base object. So if I create a new shape, this empty for example, let's just do arrows and move it alongside in our scene. That here for example. And now if we come to the main object and select the empty 0, 0, 1, which is this arrow here, it will pair the array to the object. However, watch what happens when I transform the empty. This will be better shown if I increase the count though. So you can get all sorts of interesting shapes by using this tool. The next tool is merge. If the copies of the objects are close enough to each other, the merge tool will merge the objects together. This is best shown once I apply the modifier. But first of all, I'm just going to show you what it looks like without the merge. So if I come here and apply the array modifier, and I come to edit mode, you can see that the objects aren't linked. However, if I now come back to the array modifier, select merge, and now apply, you can see the objects are now linked. You can also customize the merging distance here. So for example, if I just up the count and increase the offset here, if I was to increase the merging distance high enough, maybe let's make it 3, there we go. You can see that the array modifier is trying to merge the objects together. The UV options here just offset the UV maps of each copy by specific value that you put in here. And then the caps options just allow you to add an object to the start or end of an array. So for example, this shape here, which is called cube 004, if I just come here to cap start, cube 004, and then end cube 004, as you can see, it transforms the shape to try and fit the base object. So again, you can get some very interesting shapes by doing this. I am now just going to quickly show you how an array modifier could be useful. Let's look at this shape here for example. I'm trying to create a set of stairs. Now I could just duplicate this step here and then manually move it down, or I could use an array modifier. So with this shape selected, if I add an array modifier, I can do -1 in the z-axis, and you can see it's starting to create a step pattern. If I increase the count to 10 for example, you can see that we now have some stairs, all done through the array modifier. And then I can just apply it, and there you go. So as you can see, array modifiers are very powerful, and in my personal opinion, are probably one of the most powerful modifiers in Blender. You can create so many interesting shapes just using this tool. Another example is if you wanted to make a tower, you could use an array modifier for one window for example, and then maybe use an object offset and curve that around to make your tower shape. So really the options are limitless with this thing. So in Blender there are two ways to bevel an object. The first method is to use Ctrl+B on your object to manually bevel an edge. The second method is to use a bevel modifier to get more complex results. So I'm just going to apply a bevel modifier to this cube. Straight away you can see that the object is now beveled. And you can also come here to the amount and choose how much you want to bevel it by. But let's say you only want to bevel the vertices of the object, as by default it bevels the edges. Well, no problem. Come here and select vertices, and it will now bevel by the vertices. You can also customize the smoothness and detail of the bevel by coming here to the segments and increasing this value. Just be warned that this does increase your topology drastically if you were to apply it, as you can see. You can also bevel by different width types. You can either do it from offset, width, depth, percent, or absolute. Don't worry too much about these as they all give you the same results, it's just done through different calculations. I always use offset. The limit method field here just tells Blender where you want to limit the beveling. So on none, there is no limit, all bevels will be applied. Angle, only angles will be beveled. And you get to customize the angle where it bevels. So as you can see on the cube, we get past 90 degrees and it cancels the bevel. But anything below that, it bevels. And then weight and vertex group, which gives you a bit more specific control over your beveling. The profile option basically sets the direction or the shape of the beveling. You can come to the shape field here and adjust it to make the bevel go inwards or outwards. You can also come here to the Custom tab and use a levels graph to customize your beveling shape through these different presets. There are another two sections called Geometry and Shading, which I will not go into detail with on this video, mainly because I have never worked with a lot of these options here, and I have never needed to. Most of the powerful beveling options you will use will be up here. However, there is one thing on the Shading tab which I want to show you, which is quite powerful, and that is the material index here. This allows you to apply a separate material to your bevels based on the material index in your scene. So just to explain that, if I come over to the Materials tab here, as you can see, I have 3 materials in my scene applied to this object. Blender views these as an index. So this material here at the top is given a value of 0 on the index. This material is given a value of 1, and this one's given a value of 2. And you can move around these as much as you want. This will always be 0, this will be 1, this will be 2, and etc. It is really just a number given to a material on this list. Now with this in mind, if I was to come over to the Bevel modifier, and on the material index, I've got material preview on by the way, if I just bring this up to 1, you can see that the bevel has taken whatever material is 1 on the index and applied it, which is blue. So if we go up on the material index here and change it to 2, you can see it's now picked this material. Bevels are very useful for smoothing down edges and creating interesting shapes from your objects. The Boolean modifier is a really interesting tool. It allows us to use an object to cut into another object. So, for example, I have 2 shapes on the screen. I'm just going to change this smaller shape to display in wireframe mode, just so you can see what the Boolean modifier will do. I'm going to apply the Boolean modifier to this larger shape. Whatever shape has the modifier assigned to it will be the shape that is cut into. Now coming to this object field, this tells us which shape we want to use to cut into our base object. So I'm going to select this smaller shape here. So on our modifier screen, object, Boolean test. Now watch what happens when I move the smaller shape into our base object. As you can see, the smaller object is cutting into our larger shape here. There are three different Boolean operations: difference, union, and intersect. With difference, it simply calculates the bounds of the target object and subtracts that from the base object, like what you see here on the screen. Union adds the target mesh to the base object. So if I apply this modifier now, you can see that the target mesh has become a part of our base object. And intersect is the opposite of difference. Any geometry outside of the target object will be subtracted. Overlap threshold is just to change the maximum distance between two faces, which will change how Blender considers them as overlapping. I honestly never use this field, and you may not have to either. So before we end this video, I want to show you quickly how a Boolean modifier could be useful. Let's say you are making a post-apocalyptic scene. So I have a skyscraper here, which I made, and I'm just going to duplicate it. And then I'm going to use a wireframe modifier on this duplicate, which gives us what you could say is the framework of the skyscraper. Now I'm just going to move the wireframe into the original skyscraper mesh. And I might make this skyscraper a little bit bigger. Now I'm going to make a cube. Scale it up. Subdivide a few times. And increase the fractal amount. I'm also going to just smooth it out a little bit more. So with this skyscraper selected, I'm going to apply the Boolean modifier now, with this fractal cube being the target. I'm also just going to put the fractal cube into wire mode. Now if we move in, scale it up, you can see it's giving us a ruined look. And what you could also do is duplicate the fractal cube, move it in a bit, and then you could select the wireframe and put a Boolean modifier on that. And then select our duplicate. So it's quite rough, but you can see how we can make a post-apocalyptic scene using this. The Decimate modifier is a very handy modifier that allows us to reduce the poly count of our mesh. So for example, if we had a highly detailed model that we need to move into a game engine, we could use a Decimate modifier to reduce the poly count to make the mesh game ready. So if I apply the decimation modifier, you'll see in the mode there are three decimation modes: collapse, unsubdivide, and planar. Collapse attempts to merge vertices whilst keeping the general structure of the mesh intact. The ratio field here controls the ratio of faces to keep after decimation. On the default value of 1, the mesh is not decimated. The lower the ratio, the more decimation that is taking place. You can see the number of faces drop as we decimate the mesh. Also, just a quick pointer, decimation only works in object mode, so just remember that if you are ever using this modifier. Triangulate just converts the topology to triangles when decimating. So if I apply this modifier now, you will see that all the topology is triangulated. And vertex group allows you to assign a vertex group to the modifier so that the decimation will only apply for that group. So for example, if I select these vertices here and then create a vertex group for this, I can select the vertex group here, and now when I decimate, it will only apply to that vertex group. Unsubdivide is essentially the opposite of subdivide. It attempts to remove topology that was the result of a subdivide operation. Just be aware though, when using this does not work very well if you have made edits to your mesh after initially subdividing it. You can change the iterations count here to add more decimation. This works fine for me because there were no additional edits after this mesh was subdivided. Lastly, we have the planar, which reduces the topology on flat surfaces. You can change the angle limit here, which will take the angle of each face into account. For example, if I enter 25, it will do planar decimation to all faces which are up to a 25-degree angle. And then here you can choose which types of faces to delimit so that you have a bit more control over your mesh when decimating. I will explain all I can about the edge split modifier, and I just want to apologise in advance, as this is probably the only modifier that I have never actually used in Blender. So from what I understand, the edge split modifier basically splits out each face on a mesh. So for example, if I go into edit mode on this cube here and then move this top face, you can see that everything is linked. However, if I now apply an edge split modifier and then apply it, let me come out of proportional editing mode, there you go. So you can see everything has been split out. Now the only use I can really see for this is in a case like this. We have two meshes here which are the same to an extent. However, one of the models has denser topology and this one is low poly. Now shader smoothing will look a lot better on denser topology. So if I now smooth both of these meshes, you'll be able to see that the denser topology mesh looks a lot better when smoothed. The low poly one looks not as good. However, if I was to now apply an edge split modifier to the low poly mesh, you can see that it looks a bit better, and it's almost trying to replicate the subdivided mesh, and the smoothing works a lot better with the low poly mesh now that it has an edge split modifier on it. You can also control the angle at which you want the edge split to work on, right here. And you can also set it so that only sharp edges are split out. So for example, if I was to select all these lines here, mark that as sharp, you can already see how the smoothing's working. If I was to now apply this, and then grab all this for example, you can see that it is essentially split that part of the mesh based on the sharp edges around there. So that is a general summary of the edge split modifier. It has its uses, especially in the form of shading, and perhaps some of you can find better uses for it. The mask modifier is a very simple but powerful tool in Blender. It simply allows you to hide a specified section of geometry based on a vertex group or armature. In this video, we will just cover the vertex group side of things. So to demonstrate, here is our monkey head mesh. I'm going to go into edit mode and select these vertices here. I am then going to create a vertex group from this and assign it. Now I will apply the mask modifier to our monkey head, and then I will select our vertex group in the vertex group field here. As you can see, it hides everything outside of our grouped geometry. We can also invert this by clicking this icon right here. And lastly, the threshold value here is linked to mesh weighting. Vertices with weights less or equal to this threshold will be hidden. Weights can be customized using the weight painting feature in Blender. So when can the mask modifier be useful? A good example is if you want to mask off a character's body and then place clothes over them. The mask modifier will prevent the body and clothes clipping into each other. The mirror modifier is probably one of my favourite modifiers in Blender. It is an extremely useful tool which can be used for many 3D models. So just to give a quick explanation, the mirror modifier essentially mirrors the object along its local axes. So what do I mean by local axes? So in Blender, you have two types of axes. The global axes, which is the general values which we see here, which just tells us where everything is situated in the scene. And then we have the local axes, which is the axes specifically for a mesh. So if I zoom into the model here, you'll see that there is a tiny orange dot in the middle. It might be quite hard to make out, but it's just about here. This is the mesh's point of origin, the center of its local axes. If I move this mesh around, the point of origin will follow the center of the mesh. However, if I now go into edit mode and move the mesh, you can see that the mesh's point of origin stays in the same position. So how is this important for the mirror modifier? Well, I will demonstrate that now. I'm going to add a mirror modifier to this mesh. As you can see, nothing has really happened because the mirror modifier is trying to calculate based on the local axes of the mesh, which is this point of origin here. If I now go into edit mode again and move the mesh whilst the mirror modifier is active, you can see that the object is now being mirrored with this point of origin, this orange dot here, being the center of this operation. So for the mirror modifier, we have a few options here. First is the axes section. This simply allows us to mirror the object on a different axes. So at the moment it's on the x-axis. I could use the y-axis instead and move it this way. Or I could use the z-axis. There you go. You can also select multiple axes. So the next section here is bisect. So this basically cuts off the mirrored version if it goes into the base object. So with our monkey head here, you can see that I have it mirrored along the z-axis. By default, if I move these over each other, they just pass each other normally. However, if I now activate bisect for this z-axis here, you will see that the mirrored copy starts to get cut off as it passes the base object. The flip section works with the bisect tool and simply just flips it. So if I click Z on the flip section, you can see it's just the other way around. The mirror object field here allows you to specify an object in the scene which can act as the center of operation. So if you don't want to use the mesh's point of origin, you can create an empty. So for example, let's use plain axes and move them over here. So coming back to the mirror modifier, if we select this empty that we've just made here as our mirror object, you can see that the mirror operation is working based on the mirror object we have specified here. Clipping is very handy. Just to quickly show you, if I move these meshes into each other and then apply the mirror modifier, you will see that the topology is quite messy. Essentially what's happened is the copy's topology is just merged in with the base object's topology. However, if I now enable clipping and do the same thing and then apply the mirror modifier, you can see that the topology is nice and tidy. Even though the meshes were intersecting each other, Blender has made the topology line up very nicely. Next is the merge tool. This simply sets the distance for the copies to start merging into each other in the base object. So if I enable merge and then just increase the distance here, and let's say I move the meshes down a little bit, you can see there, based on 1 meter, they are starting to merge. And then the data section here just does the same kind of mirroring but for UV maps instead. The Remesh modifier simply changes the geometry of your mesh. There are 4 remesh options: blocks, smooth, sharp and voxel. So this isn't an advanced modifier at all, it is quite simple to use, but we will run through all of the options nevertheless, starting with blocks. So if I just apply the Remesh modifier and come to blocks, you can see it simply converts the mesh into a blocky look, similar to Minecraft actually. If we increase the depth here, you can see it increases the number of blockiness on the mesh, so you can get quite a nice terraced look. Quite handy if you want to make something like a mine temple, for example. And then scale increases or decreases the overall resolution of the modifier, which in turn changes the size of each line of blocks. And then the smooth shading option here just does the same thing as the shade smooth tool. It smooths out the shading on the mesh. In some cases, when you use the Remesh modifier on some 3D models, you may get some disconnected geometry like this. To remedy this issue, you can check the Remove Disconnected box over here. The smooth option gives the mesh a smoother look. The sharp option gives the mesh a sharper look, and then you can also adjust the sharpness here. And lastly, the voxel option just voxelizes the mesh, which I honestly don't use as it doesn't give me the control I want over my 3D modeling. The screw modifier does exactly what you would expect it to do. It creates a screw-like pattern from a mesh. So for example, if I apply screw modifier to our cube here, and then increase the screw distance, you can see that we have our new screw-like shape here. So just to quickly go through these options. Angle just adjusts the angle of the screw shape. The screw slider here increases or decreases the offset and length of the screw shape. And the iterations count here is very similar to the array modifier in Blender. It increases the number of iterations of the mesh across the chosen axis. And speaking of axis, you can change what axis you want your screw to generate on. So at the moment it's Z axis, you can do X or Y. And then the steps viewport here just increases the number of steps in the screw shape. The last thing I want to show you with this modifier is the axes object field here, which is really cool. So I create an empty over here. And then I can assign the empty to our axes object here. You can see that the screw pattern is morphing based on the position of our empty. You could use this to create some interesting staircase patterns. If you were to select the object screw box here, It gives the axes object more control over your screw mesh. So that's really the main parts of the screw modifier covered. The Solidify modifier gives our meshes thicker geometry. This could be useful in cases where we need to create something like a set of walls for a house. We could create a singular plane and then apply a Solidify modifier to it to give it more thickness. So let's go through it now. I'm going to apply a Solidify modifier to my mesh here. So if I increase the thickness, you can see that this makes the mesh, well, thicker. You can also apply an offset to the mesh if you want to do that. When you use this modifier in a mesh, it applies the thickness based on each of the faces of the mesh. So you may get some parts of the mesh that appear thicker than others. If you want even thickness, then just select this option here for even thickness. Fill just adds a filler to thickness here. So if I toggle this off, you can see that we don't have the geometry in the middle. This can be quite useful for game models where you don't want extra topology sitting in places where the player will never see it. The only rim option here will just add the geometry for the rim of the thickness. So you can see that it's not added the innermost geometry. And then similar to other modifiers, you can add a vertex group here so that only that group is solidified. These other two sections are quite self-explanatory. The normal section here allows you to flip the normals or give them higher quality normals. And the materials options here just allow you to offset the material or apply a new material to the rim. So this rim option here is actually very useful. So if I come to the materials section, I'm just going to add 3 materials. And I'm just going to give them different colours. So we can give this red, this can be blue, and this can be yellow. Now if you remember in a previous video where I discussed material indexes in Blender, Blender reads the material list here as an index. So this is index 0, this is 1, this is 2, etc. So if I go into material preview mode, by default it's going to apply 0. Now keep in mind, with this being 1 and 2, if I come to the modifier and change the rim to 1, you can see it has taken index 1 into account, which is our blue material here. If I go into 2, this should become yellow. As you can see, the rim is just changing the material of the rim of the thickness here, which can be very handy. The edge data section here only works when you use a subdivision modifier along with the Solidify modifier. So if I just come to this mesh over here, you can see that this mesh has a Solidify modifier and a Subdivision modifier applied to it. If I use the creasing options, you can see that I can apply creases to different parts of the model, which just gives you a bit more control when using a Subdivision modifier. The thickness clamp allows us to control the interior part of the mesh when using the Solidify modifier. This is useful in cases where, for example, we've turned the thickness up to a point where the mesh begins to intersect with itself. If I use the clamping option here, you can see it prevents that self-intersection by dialing back the thickness a little bit. With the angle clamp enabled, it will make the clamping also consider angles. If we come back up to the top here, you can see that we can change our thickness mode from simple to complex. Complex mode uses another form of logic to create thickness for our geometry. If you are having strange results using the simple mode, try using complex mode instead to see if the results look better. You can manipulate the results here using the offset, or change the thickness mode. Just be warned that the complex mode takes a little bit longer to calculate thickness than its counterpart, simple mode. The subdivision surface modifier could be the one modifier you use the most in your 3D modelling. Very similar to the manual subdivide tool, this modifier subdivides the geometry of your mesh to add greater density and detail to it. If I now apply the subdivision surface modifier to my cube here, you will see that it becomes more round. This is because we are using the Catmull-Clark mode. If I switch over to simple mode, it will retain the shape of the mesh. So if I just up the subdivision count here and then apply it, you will see that our mesh now has more density. So we know that the simple mode retains the shape of the mesh and adds more density, but what is the Catmull-Clark mode? The Catmull-Clark mode is a subdivision algorithm that is used to create smooth surfaces, so it is essentially smoothing out the corners of our mesh. I will put a link in the description of this video if you want to read up on this algorithm a bit more. If I keep subdividing this mesh, you'll see that our cube eventually becomes a sphere. Now this modifier gives us a bit of flexibility. You can set the number of subdivisions that appear in the 3D viewport, but you can also set the number of subdivisions that appear in renders. So if I put 1 in the levels viewport and 2 in the render, and then if I render this object, you can see that the render is showing off more density because we have told it to do that in the modifier, so you can see the difference in detail. Optimal display just changes the look of the mesh when it is in wireframe mode by not rendering the new subdivided edges. This is good for performance purposes if your computer is running a bit slow. Under the Advanced tab, we have the Quality field, which just makes the vertices position more precise when subdividing. This is more easily visible on a higher subdivision level, like 4 for example. If I change the quality around, you can see how some of the vertice position is becoming smoothed. The UV smoothing option here just chooses how you want the UV islands to be changed when subdividing. You can select smooth to smoothen out the UV islands, or you can select sharp, which prevents the modifier making any changes to the UV islands. So the Triangulate modifier does exactly what it says. It turns your mesh from quads to tris. So just quickly before we get into the modifier, a quad is a polygon with 4 sides, and a tri, or triangle as it can be called, is a polygon with 3 sides. To demonstrate the modifier, I'm going to apply it to our monkey head here. First of all, before I apply it, if I go into edit mode, you can see that the mesh is made up of quads. You see 4 vertice faces. Now with the modifier applied, you can see how it's changed the mesh to be triangulated. 3 vertice faces. There are 4 methods to triangulate our mesh. Beauty, which splits the quads into triangles in a neater manner, which retains the general shape of the mesh as much as possible. Fixed, which splits the quads on their first and third vertices. Fixed alternate, which splits the quads on their second and fourth vertices. And shortest diagonal, which splits the quads based on the diagonal distance between each of the vertices. The next section we have here is polygon method. So whilst the quad method here only works for quads, the polygon method applies for n-gons. So what is an n-gon? An n-gon is a face, or polygon, that consists of more than 4 vertices. If I come to the back of the monkey head here, and go into edit mode, you can see that we have an n-gon right here. 1, 2, 3, 4, 5. So this face consists of 5 vertices. So we can set the triangulation method for n-gons using this polygon method right here. Beauty gives us the best results, and Clip gives us a slightly rougher result. And again, Polygon method only applies for n-gons, Quad method applies for quads. The minimum vertices option here basically tells the modifier how many vertices a face must have before it is excluded for triangulation. For example, it is currently set to 4. This means that if the face has a minimum of 4 vertices, it will be triangulated. So obviously, the entire monkey head here is being triangulated because it was made up of quads which consist of 4 vertices. However, let's say you had a face which had more than 4 vertices. Well, this is our n-gon right here, which has 5 vertices. If I now set the minimum vertices to 5, it will take the n-gon into account, but the modifier will now ignore everything else that had less than 5 vertices, which was the majority of our monkey head. So you can see that the triangulation is not being applied to most of the mesh, only this n-gon here. The wireframe modifier transforms a mesh into a skeleton of itself. It takes all of the edges of a mesh and turns them into 4-sided polygons. So this is a really cool modifier, and you can make a lot of interesting shapes using this. I'm just going to add the wireframe modifier to this cube on our viewport, and straight away you can see what has happened. I can adjust the thickness, and I can also offset it. So let's say I wanted to create a quick window. I can just come into edit mode, subdivide one of the sides of the cube, go back into object mode, and there you go. The boundary option creates wireframes on mesh islands. I have never used this option personally. Checking the replace original option here allows you to get the original mesh back, but with the wireframe on top of it. So you now get that nice border around the cube. Even thickness will create thickness whilst taking sharp corners into account. Relative thickness will determine the thickness of the edges by the length of the edge. So for example, longer edges will be thicker. The crease edges option here is only used along with the subdivision modifier to give you more control over the process. So if I add a subdivision surface and now enable the crease edges, you can see that I can manipulate it. And the material offset option here just reads whatever material is on the material index of the mesh. So for example, if I create 3 materials, blue, red, and yellow. So Blend will read this as an index. This is 0, this is 1, and this is 2. If I now come to the modifier, I'll just turn on material preview first. So if I come to the wireframe modifier, at the moment it's set on 0. If I change this to 1, you can see it's now red, because red is at index 1. So if I go to index 2, it should become yellow. And then the vertex group option here just limits the modifier to that group. So for example, I can assign this face here to a vertex group. If I now select that vertex group, you can see the wireframe is only being created for that vertex group. I can adjust the factor value here to retrieve more of the external geometry. You can also click this button here to invert the values. The cast modifier allows us to morph our mesh. It is better shown if I subdivide our cube here. I'll just do this a couple of times. Now if I apply the cast modifier to it, you can see that it is getting a more spherical shape based on the options set here. So I can choose sphere, cylinder, or cuboid, which won't really make much of a difference because it was originally a cube. So if we go to sphere, the factor will morph it in a more spherical way to a point where it just starts to go off and do its own thing. The radius basically controls how much of the shape gets this effect. So you could just do it there, for example, and then turn the factor up, and you've still got some of the cube geometry there. And then size won't do anything whilst this box is checked. So currently we are getting the size from the radius. You can see that the size of the cube grows as we expand on the radius field. If I check this box, the size field will control the size of the cube, and the radius will no longer affect the size. And you can get a few more interesting shapes using it this way. The object field here allows us to morph the shape based on another object. So I've got an empty here, which is these arrows. If I select this in my object field, and then if I move the object closer to the mesh, you can see that it will morph the cube as we move the object around it. You can also allow the mesh to be modified based on the transform values of the object that is assigned here. So if we click use transform and then I click on the empty, if I scale up the empty or scale it down, you can see that the cube is taking the transform values from our empty. Anyway, I hope this video has helped you. The cost modifier can give you some cool results. There might be some times where you want to use it. I personally don't use this modifier that much. I think I've only used it once or twice before. But feel free to play around with it and you might get some interesting results. The simple deform modifier allows us to quickly deform our mesh in a number of ways. If I apply this modifier to our cube here, you can see how it deforms straight away. There are 4 deformation options: twist, bend, taper, and stretch. Each option will have a factor or angle slider up here where you can adjust the level of deformation to the mesh. The origin here allows you to assign an object which will act as the master of the deformation. So if I create an empty and then assign that empty as the origin, you can see that I can now manipulate the deformation of our mesh using our empty. You can also choose what axes the deformation occurs on. The limit sliders here allow you to simply customize the limits of the deformation. And you can also lock them down on a specific axis so that they will not deform on that axis. It's a very simple modifier to use, and I'm sure you'll be able to find many uses for it. So that's it for this video on intermediate level modifiers. I hope this has helped you and open up the world of modifiers to you. You will find yourself using modifiers quite a bit in your 3D models, as they grant you a lot more flexibility and power with your modelling. Any modifiers that were missing in this video will be explained in future videos. I just want to take this slowly and avoid throwing in too much in one go. Stay tuned for the rest of the Blender Intermediate tutorial videos. This is going to be a very exciting series, where at the end of it you will become skilled enough in Blender to go off and create whatever you like. I will see you all in the next video.